Alright, so welcome to my video today. I'll be talking about how to create a simple circuit to blink an LED on Tinkercad. So to do that, you need to have an account with Tinkercad. Tinkercad is a platform created by Autodesk. If you don't have an account with them, you can watch this other video of mine where I've talked about creating an account. So today, let's get into creating a simple LED blinker with Tinkercad. So first, I'll come to create and click on circuit, since we are creating a circuit, and I'll wait for that to open up. Yes, so this is how the dashboard looks like, where I can create from. On your right hand side here, you can see the components. We have the basic, we have the all. So if I click on all, you can see all the components currently supported by Tinkercad. For now, we'll be working with the Arduino Uno. So you can also search from here, Arduino Uno, and I drag that out. Then I'll also need an LED. So let me bring out my LED. Sorry, not the code. LED. Okay, this is fine. I would like to change the color to green. And then finally, I'll bring out a resistor. A resistor is used to limit the amount of current that flows through a circuit. So that's important because according to the design of this Tinkercad dashboard, if you don't connect your LED to a resistor, it shows as if it has burnt out. I'll do that just before I bring the LED in. So let's move on with our connection. One thing we can do here is to change the direction of our LED and other components. This is the cathode, which is the negative terminal, and this is the anode, which is the positive terminal. Because I would like to connect the anode to pin 13 here, I want it to be on the left hand side. So while I click on the LED, I can click on the mirror component, and that changes the direction. So now if I click on the anode, I can draw a line which is actually like a wire. Get here and draw it down to pin 13. I can adjust that to be straight. Because I'm using that as my positive, my anode, I would like to make the color red. Then for the other one, which is the cathode, I can bring that down and use any of the GNDs I have here. So I'll use this one, and I can adjust that so it fits well. So I'll use this as a black. Take note, I can also use GND from here. So the Arduino board has 3 GND ports or pins, and I can use any of the 3. Alright, so for us to work with this, anytime you're using the Arduino board, you need to write a code to it, because right here we have a microcontroller which accepts the code. So if I click on code here, there should be a default code written for us for blinking the LED. That's the default code that comes with Arduino. So from the blocks, if I'm to remove all this, let me remove this and I'll rewrite it from the beginning. So I'll come to control and bring out this on start. That is a block that tells Arduino what to do when it is powered up. Then I'll bring in a forever loop. The forever loop is very essential because it is the one that runs our code over and over again after we've written it. So having brought out that, I can now come to input, output, math, variables, notations, and these are all different kinds of blocks we can use here. But the one we're going to use right now is the output, because we want to display something to the LED. So the LED is an output device, and I'm going to be working with pin 13 now. I can use this set built-in LED, because pin 13 is actually the built-in LED pin that has been set by Arduino. So setting it to high means I'll turn it on. Then I come back to control and put a delay of 1 second. Of course, I can change that, but let me leave it at 1 second for now. And instead of going back to create another one, I can easily duplicate this by right clicking, and then I place it here. Then I change this to low, and this is the code we saw initially. So what this code is telling us is that after Arduino starts up, this loop continues over and over again, it first of all sets this built-in LED pin, which is this pin 13, as high. That is, it turns it up, then it waits for 1 second, then it turns it off and waits for 1 second, then goes back to the beginning. So now let's test the code which we have written right now before I put in the resistor. So you discover that as I'm running it now, it's showing a kind of sign that the board is burning out, and that is because I didn't connect a resistor to it. If you look at the warning here, it says the current through the LED is 24 point. Okay, it's changing values, but it's saying the recommended should be 20 milliamperes, but what is entering the LED right now is over 20 milliamperes, and that's why it is showing this. So in order to correct this, I'll stop the simulation because I can't make edit while simulating. Let me delete this wire and connect my resistor to this. The value now is 1k. I can change this to 220 ohms, which still works. Then now I connect my wire back to this. So what this does is that the resistor will limit the amount of current entering into the LED. So now by the time I start the simulation again, you can see the LED is blinking without having that sign coming up, the explosion sign. So this makes it safe. In real-time circuits, you may not need to connect your resistor to the LED for it to work because the current is kind of regulated, but it's always an advisable thing to do just to protect your component, especially the LED. So I hope you enjoyed this video, and I'll see you in the next one. Thank you.